Every single day, modern organizations capture absolute mountains of text, interview transcripts, internet reviews, and angry social media posts. This qualitative data is richly and emotionally detailed, but because it lacks a mathematical structure, it is notoriously difficult to quantify or analyze objectively. To process this information, researchers rely on a strict systematic architecture. They run subjective texts through an analytical engine to build verifiable, objective theoretical frameworks. This matrix classifies the exact events that trigger customer anger in service industries. It is the destination of a major qualitative case study. Arriving at a clean, organized matrix requires heavy lifting. It demonstrates that qualitative research relies on highly engineered processes to extract facts from human emotion. In the absence of strict quantitative rules, the accepted standard for processing textual data comes from the work of researchers Miles and Huberman. Their framework starts with data reduction. This is the process of selecting, coding, and categorizing the raw text into manageable pieces. The next step is data display. The reduced data is presented in matrices or graphs to reveal underlying patterns. Finally, researchers apply drawing conclusions. They test the displayed patterns to make valid inferences about the subject. These three steps do not form a straight line. They operate as a continuous, iterative loop. Developing preliminary conclusions actively feeds back into how the raw data is categorized. We can see how this engine works by returning to the starting line of the customer anger study: 859 raw, unstructured stories collected from angry customers. The researchers first applied data reduction, stripping away conversational filler to isolate the actual variables. They do this by establishing a coding unit. While you could count individual words, the most analytically useful unit is a theme, a single assertion about a specific subject. Consider this actual response. After 3 cigarettes, there was still no check. I saw the waitress having a lively conversation with the bartender. The researcher separates the expectation of getting the check. Themes convert subjective human storytelling into a reliable, quantifiable dataset. Once the text is broken down into hundreds of individual codes, those codes must be organized into broader categories to build out a theory. Researchers can map data onto a list of codes from existing theories, known as deductive categorization. Alternatively, they can use inductive categorization, often called grounded theory, where the categories emerge entirely from the raw data itself. This raises a methodological problem. How do we verify the researcher isn't just grouping data to fit their own assumptions? The solution relies on multiple independent judges. These judges are given the exact same critical behaviors and asked to sort them into buckets without consulting one another. This overlap is called inter-judge reliability. It measures the percentage of agreement between independent coders. Rigorous studies require an agreement rate of 80% or higher. Multi-judge categorization provides the mathematical bridge that validates the research, proving the patterns exist within the text and not just in the researcher's mind. There is a tension in this methodology, the Casargian trade-off between statistical reliability and diagnostic relevance. Creating incredibly broad categories guarantees near-perfect interjudge reliability because the choices are too simple to debate. A 1949 study categorized anger into just 2 massive buckets. The scale tips heavily toward reliability, but knowing an event is a need situation gives managers 0 actionable information. Contrast that with the customer anger study, which shatters the data into 28 specific subcategories, bringing the scale into perfect balance. A well-designed qualitative study must intentionally sacrifice perfect reliability to achieve actionable, real-world relevance. This brings us to the second phase, data display. Raw lists of hundreds of codes are cognitively impossible to analyze without visual architecture. This matrix shows the reduced data from the anger study, populated with subcategories and percentage columns. By isolating columns tracking the frequency of behaviors, the researcher can spot dominant outcome failures. Separating single-factor from multi-factor incidents reveals compounding variables. Waiting is frustrating, but escalates to anger much faster if staff are also rude. Seeing the data displayed like this often exposes initial errors. The researcher might realize their early codes were too broad or completely wrong. These preliminary visual conclusions actively feed back into the raw text, forcing researchers to recategorize data based on the new patterns. Data display serves as an active, functional tool designed to expose invisible relationships within the text. The final phase is drawing and verifying conclusions. The immediate question is how researchers know these final conclusions are universally valid, and not just cherry-picked anecdotes confirming an internal bias. The first validity check is numerical. All generalizations are strictly supported by counting the frequency of events to prove statistical significance. The ultimate stress test for qualitative theory is the deliberate inclusion of deviant cases. This scatter plot shows the concept in action. Researchers actively pull out an anomaly or a story that contradicts the proposed theory, forcing them to either adapt the model or discard the hypothesis entirely. Actively hunting for data that breaks the model is what elevates qualitative findings from subjective opinion to validated, rigorous science. This meticulous methodology is critical in the modern digital era, where unstructured textual data is expanding at a massive rate. This environment is defined by three core characteristics: the massive volume of data, the variety of formats, and the velocity at which it is generated. To that, researchers add a final metric, veracity, which accounts for the noise, inherent bias, and abnormality hidden inside massive datasets. While our technology to capture and store data has evolved exponentially, organizations still struggle to extract reliable value from it. Even advanced machine learning and natural language processing tools rely on the core architecture of data reduction, categorization, and display. The sheer scale of unstructured data in the modern world may be vast, but the architectural blueprint for finding objective truth within human narratives remains exactly the same.